today's explainer. Today, we're going on a math adventure as number detectives to decode some truly giant numbers. If you've ever felt totally overwhelmed when the digits just keep piling up, don't worry. We're going to unlock the hidden secrets of place value together and transform you into an absolute master builder of mathematics.
Okay, let's dive right into this massive four-digit beast, 6748. To an untrained eye, it just looks like a random, intimidating string of big numbers.
So, how do we make sense of something towering this high? It can definitely look pretty scary at first glance. But what if I told you there's a secret code to break it all down? What if it's not actually one giant, unmanageable number, but a really clever combination of smaller, easy-to-understand pieces?
Well, to solve this puzzle, we have to start by taking these giant numbers completely apart, piece by piece. Think of it like reverse engineering a giant Lego castle. You really want to see every individual structural brick that holds the whole thing up.
We do this by using something called expanded form. Essentially, this means we are treating each part of the number like different sized building blocks based on their place value. So you've got your massive thousands blocks, your large hundreds blocks, your medium tens, and your little individual ones. Now, watch how this works in action. We can visually stack these blocks, starting with the thousands way down on the bottom, all the way up to the ones at the top, to magically form 6,748. We take 6,000, layer 700 right on top of it, drop in the 40, and cap the whole thing off with the 8. Suddenly, that huge, intimidating number makes perfect sense, doesn't it?
Okay, so once we know how to completely smash them apart into these foundational blocks, we can start the really fun part, putting them back together and giving them their proper names in the written world.
Because we understand the expanded form, it makes it absolutely super simple to translate those digits into exact written words. Look at this one. We know there's a 5,000 block, 0 hundreds, a 30 block, and a 3 block. Because of that, we can easily read it as 5,033. You literally just read the blocks out loud.
All right, let's jump into a rapid-fire workshop and see how this builds. Try to guess the final combinations of these two addition patterns right in your head. Remember, visualize those different sizes of place value blocks sliding together. Boom! That first one stacks up to become 1,330. Notice how there are no loose ones to add at the end there? So we just cap it off with a 0.
And the second one? It snaps together perfectly to make 8,303. Now, did you catch that? There were absolutely no tens in that equation, so we have to place a 0 right in the middle to hold that place value open. It's a crucial step.
Right, so the more we practice translating these numerals into words, the better we get at instantly recognizing the unique place value of every single digit. Take this combination. The digits 2415 decode instantly into 2,415. You are officially speaking the language of the thousands.
All right, Master Builders, now that you've got expanding and combining down, it's time to shift gears a bit. We're going to face a classic number detective trap. Understanding a single number is great, for sure, but what about the vast spaces sitting between them?
I want you to think about this carefully. If we're counting numbers starting at 1,000 and going to 1,200, how many numbers is that? Now, your brain probably wants to jump straight to a quick subtraction problem here, but hold on just a second.
Here's your clue. Consider the inclusive nature of the span. Our master blueprint warns us to be really careful here. When figuring out how many numbers fit in a range like this, we're looking at the true distance, or the jumps, from the starting line to the finish line.
Which brings us to a really neat, round conclusion. The difference is exactly 200 numbers. It's one of those brilliant little rules of mathematics that totally test how carefully you're observing the boundaries of your numbers.
So, using that exact same detective logic, I want you to think about how many numbers exist in this slightly smaller range. How many steps are there sitting right between 1,000 and 1,100? I'm going to let you chew on that one and apply the rule for yourself.
Okay, before we wrap up this explainer, we have one final, ultimate puzzle to see if you've truly mastered the thousands.
First, a quick warm-up. Keep that visual stacking trick in your mind for this, layering the thousands, hundreds, tens, and ones. 7,000 plus 500 plus 20 plus 4. They slide perfectly together to make 7,524. Super smooth and easy.
Now, for the final boss, I'm going to leave you with this provocative puzzle to solve on your own. If you have 4,205, can you successfully stack these specific blocks? Can you find the hidden 0, write the digits out perfectly, and give this number its true name in words? Keep exploring, keep stacking those blocks, and I'll catch you in the next explainer.